Assalamualaikum and hi everyone. We are group 3 from S59. So, have you ever thought about how we can predict the future of a country using maths? Argentina's population growth isn't just a social topic, it is a perfect example of how mathematics can help us understand and solve real world problems. In this presentation, we will explore how Argentina's population changes over time and how we can model this using first order differential equations and numerical methods. Our goal is to show that maths isn't just about solving problems on paper. It is a powerful tool for making predictions and analyzing real data. So let's dive into how Argentina's population growth tells us a story through number, equations, and smart calculations. There are four objectives. First, CLO2 demonstrates self-awareness and self-confidence using quantitative and qualitative approaches in addressing concrete scientific issues. Second, PLO4 demonstrate interpersonal skills. 3. CLO4 demonstrate the ability to express new idea and interest relating to numerical concepts for selected case study. And lastly, PLO6 use basic digital technology application to support study.
Here is the table of population in Argentina from 2000 to 2020. Next, here is the table of predicted population value in Argentina from 2000 to 2020 by using the particular solution.
After getting both graph from plotting data from predicted value and the actual value, we can combine both of the graph to analyze the similarities of the shape and pattern of it. When we combine these two functions together, we can see that they have a slight mismatch or difference in the progression value, indicating that there are slight difference in the value from the predicted value and the actual value from the data.
To determine the future value of population in Argentina, we choose the year of 2021, which indicate t equal to 21. So, we substitute the t equal to 21 into the particular solution equation. Hence, the value we got is 46,786,027.
Next, to determine the past value of population in Argentina, first we choose a year as our test value. We choose the year of 1999, which indicates the t is equals to -1. So we will substitute the t equals to -1 in the particular solution. Hence, the value we got is 36,810,554.
Now, we can calculate the percentage error of the data obtained from the particular solution and the predicted value. We can use the formula of percentage error, which is the actual population minus the predicted population and divided with the actual population multiplied with 100%. We then need to calculate the percentage error for every year from the year 2000 until 2020. For that, we need to calculate the average percentage error, which is the sum of all percentage error in those years divided with the number of year or t, which represents time. In this case, the value of t is 20 or 20 years. After we total up the value of percentage error for the whole 20 years, we can divide it with the number of years, which is 20, and multiply the value by 100%. And from here, the average percentage error over the past 20 years using the predicted population values is approximately 0.8136%. So, for the discussion in task 1, why was there difference in the actual value and the calculated value from the particular solution? The reason for this is because the simplifications in the model. So, most general solutions often rely on simplifying assumptions and it assumes a constant growth rate. However, this value was not constant. They fluctuate due to several factors. First of all, the declining fertility rates. The fertility rate of Argentina has been on a long-term decline and the value even accelerated during 2000 and 2020. This happens because of the access to contraception and family planning, with smaller families being more common and accepted. Increased female education and labor force participation also lead to delays in marriage and childbearing, ultimately leading to smaller family sizes. Second, the economic instability and inflation. The 2001 until 2002 crisis was the collapse of convertibility plan, sovereign debt default, and the subsequent correlative of freezing of bank accounts, which triggers massive social unrest. Next, post-crisis recovery and subsequent volatility during 2000 to 2020, where high inflation, currency devaluations, and recurring periods of recession continued to plague the country. Lastly, those with higher educational skill often move out from the country to seek better job prospects and salary to sustain themselves. Next, what has affected the growth population of Argentina in the past? First up is the massive European immigration. One of the main contributors is the Spanish colonization period during the 18th to 19th century, where it involved large-scale immigration of people from colonizing powers such as Spain and Italy to establish permanent homes and societies in new territories. The settler population were then grew rapidly, altering the demographic makeup of these regions. Immigration from the neighboring countries during the 20th century, such as Bolivia, Paraguay, and Peru, were mainly driven by economic disparities, labor demands in Argentina, and political instability in their countries. On the other hand, the Dirty War, or Guerra Sucia, was the large contributor affecting the population rates. It is a period of state terrorism carried by Argentina's military dictatorship or Justa from 1974 to 1983. The Argentinians were repressed by kidnapping the newborns, sexual violence, and forced disappearance, where they were taken by force from families to be executed. This leads to emigration of Argentinians to seek refuge from the neighboring countries. One, what will affect the growth population of Argentina in the future? One of the factors is future emigrations. Argentina's persistent economic challenges, including high inflation, periods of recession, and lack of long-term stability, can incentivize individuals, especially those with high levels of education and skill, to look for more promising futures elsewhere. There will also lack of career progression where some workers or professionals may feel limited in their career growth opportunities in Argentina compared to what's available internationally. After that, the aging population of Argentinians were also the candidates of the factors that will affect the population of Argentina in the future. The percentage of Argentinians with the age of 65 and older have been steadily increasing. This group constituted around 12.4% of the total population, which is a rise from 9.6% in 2000. Projections also indicates that this trend will continue, with older adults making up a significantly larger share of population in the coming decades. The rising of the median age, which indicates a shift towards an older demographic profile towards the 40 years old. This causes intergenerational equity, where the changing age structure can raise questions about intergenerational equity and burden placed on the working age population to support a larger older generation. Besides from that, older generations have to have a greater healthcare needs, which can strain the healthcare system.
The conclusion of the task 1 is, by using the first-order differential equations, the estimated growth of populations in Argentina has increased exponentially from year 2000 to 2020 and will continue to grow throughout the year proven by the particular solution we have calculated. This increase is driven by many factors including improvement in medical aspect, economy, and urbanization. The calculated percentage error influenced by many factors including higher than expected birth rates, rapid urbanization, political factors, and internal migration due to economic opportunities. Task 2, numerical method. The question is estimate the area bounded by the curve fx equal to negative 5x cubed ln sine x squared. The x-axis given is x equal to 0.5 and x equal to 1 using trapezium rule with 6 and 10 subintervals. State the final answers correct to 6 decimal places. To find the area using trapezium rule, we divided the area under the curve into many equally trapezoids, which can cause subintervals to approximate the area under the curve. The n subinterval trapezoid approximation is given by the equations.
This is our graph for task 2. The red curve represents the function of fx equal to negative 5x cubed ln sine x squared. This function plotted the coordinate plane and its complex behavior due to the combination of a cubic polynomial, natural logarithmic, and sine function. The shaded green region under the curve is bounded between x equal to 0.5 and x equal to 1, where 0.5 less than x less than 1, and it represents the area under the curve from 0.5 to 1. The value of definite integral from 0.5 to 1 of the function given above is equal to 0.58382. The value corresponds the actual results to the total sine area under the curve within the specified interval. The green shaded region also includes the condition which is y greater or equal to 0, meaning only the portion of the function above the x-axis is considered for shading.
So this is our table for 6 subintervals. Then we fill out all the columns in the table. Then we multiply 1/2 with the sum of the coefficient times with fx and with the value of h to estimate the area bounded by the curve, which is 0.579982 units squared.
This is the table of 10 subintervals, and we use the same method as we used for 6 subintervals. From this table, we can say that 10 subintervals more accurate than 6 subintervals. The conclusion is the greater the number of subintervals, the closer the estimated error obtained to the actual value. Therefore, the approximation will become more accurate as the number of subintervals increase.